Good afternoon, class. So again, we are talking about types of energy. And the last class period, we talked about kinetic energy. And kinetic energy is the energy of motion. We talked about that kinetic was just a fancy word for motion. And the formula we used that was dependent upon both just mass and velocity was kinetic energy equals 1/2 the mass times the velocity squared. Today, we're going to look at the other type of energy, which is called potential energy. And it's an energy of position or energy that is stored. It's energy that is not in use, but may be changed to kinetic energy. So examples of that would be a person even on the top of a step getting ready to jump down, or a rock on top of the hill, or food is stored chemical energy. You eat that and it makes you able to move and breathe and do things. So if we look at this a little bit closer, there are three types of potential energy. One is elastic. That is energy that is stored when objects are compressed or stretched out. So a spring, like that's in my pen, is stored energy. It makes the ink pop back out. Rubber bands are also a type of stored elastic energy. The another type is gravitational potential energy. This is the one that, again, that we're talking about an object is up above, higher, and able to fall down or roll down a hill or something like that. And the formula that we're going to use is potential energy, PE, is equal to mass times gravity times height. And they put this little g here just to make sure that you understand that we're talking about potential energy that is gravitational potential energy. Because there are formulas for elastic potential energy, but we're not going to discuss those. So really, we're just going to use this formula, and I'm going to write it all the time. It's just PE equals mass times gravity times height. The other type of stored energy is all the ones that you see here: food, rocket engines before they ignite, dynamite, gasoline in your car, wood, if you're going to burn it, is a stored energy. You get heat from it when you burn it. So those are all energies that are stored by chemical bonds, and as you break those bonds, energy is released. But what we want to be able to do is go on to our homework. So if we go to today's homework, we can see, if you download the worksheet, our gravitational potential energy. And we have here in this example, we have a boulder sitting on top of a hill and it's going to roll down or fall off this cliff. So in these problems, if we do our given first, we know in this one, since our formula is always going to be potential energy is mass times gravity times height. So if I do my given, I have potential energy, I have mass, I have gravity, and I have height. I look to see what they gave me. I have a boulder, which is mass. The 64 kilograms tells me that it's mass. I know gravity is just 9.8 meters per second squared. And they gave me the height is 523 meters, and they want me to find the potential energy. Well, I can just go plug all these in. And I use, again, I'm showing my units always, what I'm doing. Now, potential energy always has the units of joules. And a joule is equal to a Newton meter. And a Newton is equal to kilograms meters per second squared. So if I want to check real quick that I have all the right units, I have kilograms, I have meters per second, and I have a meter. And those two combine to make a Newton. So I have all the right units, everything's going to work out. And my answer, if I plug it into my calculator, is 328,026 joules. That's how much kinetic potential energy that boulder has sitting up on top of the hill. So now you should be able to go on and do the rest of the homework with no problem. Just again, take the time, set up the givens, show me the formula, and everything will work out just fine. So I will see you the next class period.